Orth4 dot test. Now let's start with introduction. Orth4 dot test is a simple clinical test mainly used for assessing a patient's degree of binocular vision or the status of peripheral binocular cooperation. The Orth4 dot chart contains 4 dots. One red dot is always at the top, 2 green dots at either side, right and left, 1 white dot is always at the bottom. This test can reliably be conducted on preschoolers as young as 2 years if they are allowed to point to the dots. Now, methods of Orth4 dot test. There are 2 methods of performing this test. One, distance Orth4 dot test. In this test, target fixed at 6 meters from the patient, which may either be contained in an illuminated box or projected on a screen. Here in this figure you can see the illuminated box with Orth4 dot chart. 2. Near Orth4 dot test. In this test, the target is fixed at 33 cm from the patient, which consists of a flashlight helps to alter the projection angle. Here in this figure you can see the flashlight containing the Orth4 dot chart. Now, requirements to perform Orth4 dot test. 1. Patient. 2. Trial frame. 3. Illuminated box or flashlight. 4. Red-green filter. Now, procedure of Orth4 dot test. A. Patient preparation. Tell the patient about the procedure of the test. Tell that not to squeeze eyes and look through the both eyes. B. Test procedure. Ask the patient to wear the trial frame. Place the best refraction correction and then place the red-green glass over the patient's correction. Red filter over the right eye and green filter over the left eye. In a slightly dim room, turn on the flashlight slightly below the line of sight. Now to test right eye, cover the left eye and ask how many dots does they see now. They should report 2 red. To test left eye, cover the right eye and ask how many dots does they see now. They should report 3 green. For the binocular test, with both eyes uncovered, ask a third time how many dots does they see. If normal fusion is present, they should report 4 dots. Now, interpretation of Orth4 dot test. Patient response 4 dot, 1 red dot in the top, 2 green dot in either side, and 1 orange dot in the bottom. In Orth4 dot chart, there are also 4 dots, 1 red dot in the top, 2 green dot in either side, and 1 white dot in the bottom. That means patient seeing exactly what in the chart. Final interpretation, binocular single vision. Patient response only 3 green dots. As green filter placed before the left eye, that means patient is seeing through the left eye and right eye image is suppressed. Final interpretation, right eye suppression. Patient response only 2 red dots. As red filter placed before the right eye and patient is seeing only 2 red dots, that means left eye image is suppressed. Final interpretation, left eye suppression. Patient response 3 green dots and 2 red dots alternatively. That means right eye image and left eye image are suppressed alternatively. Final interpretation, alternate suppression. Patient response 5 dots, 2 red dot in right side and 3 green dot in left side. That means right eye image on right side and left eye image on left side. And if we draw their line of sight, they are not crossing each other. Final interpretation, uncrossed diplopia. Patient response 5 dots, 2 red dots in left side and 3 green dots in right side. That means right eye image on left side and left eye image on right side. And if we draw their line of sight, they are crossing each other. Final interpretation, crossed diplopia. Patient response 5 dots, 2 red dots up and 3 green dots down. Remember, higher image belong to lower eye and lower image belong to higher eye. Final interpretation, vertical diplopia with right hypotropia. or left hypertropia. Patient responds 5 dots, 2 red dots down and 3 green dots up. Final interpretation: vertical diplopia with left hypertropia or right hypertropia. Now, indication of Orth4 dot test. 1. Manifest strabismus. It helps to identify vertical and horizontal manifest strabismus. A. Esotropia. B. Exotropia. C. Hypertropia. D. Hypertropia. 2. Diplopia. This test can help in determining the nature and type of diplopia. A. Crossed diplopia. B. Uncrossed diplopia. 3. Suppression. It helps to identify which eye is suppressed. Bruckner test. Introduction of Bruckner test. The Bruckner test is performed with direct ophthalmoscope to identify emmetropia and other abnormalities of the eye. Being an objective test, it can be used among preverbal children and uncooperative patients. Both eyes of the patient are simultaneously illuminated from approximately 1 meter distance. Now let's see what are the requirements to perform Bruckner test. 1. Direct ophthalmoscope. 2. Patient. Now let's study about the procedure of Bruckner test. Dim the room lights. Examiner sits at a distance of 1 meter from the patient, and patient looks straight at the examiner. Turn on the ophthalmoscope with illumination of large white spot. Direct the light directly at the patient's eye using the large white spot and focus on the iris. Now assess the red reflex. Quality and intensity, size of the pupil, position of the light reflexes, quality of the corneal light reflexes. The reflexes should be mirror image of each other. Now, interpretation of Bruckner test. 1. Hyperopia. The lighter crescent is visible at the top of the red reflex. With increasing degree of hyperopia, the red reflex will become dimmer. 2. Myopia. The lighter crescent is at bottom of the red reflex. 3. Astigmatism. The red reflex flattens into a straight line across the pupil rather than a crescent. 4. Anisometropia. The color of the red reflexes are different. The size, position and color of the crescents are also clearly different in each eye. 5. Media opacities. Corneal abrasion and corneal scar will appear as black marks on the red reflex. 6. Retinoblastoma. Loss of red reflex and development of leukocoria or glucocoria or white reflex. 7. Strabismus. Asymmetry of red reflex, unequal pupil size, displacement of central corneal light reflex. 8. Esotropia. The red reflex will be brighter on the eye that goes inward. The white corneal reflex will be moved outward toward the exocanthus. 9. Exotropia. The red reflex will be lighter on the eye that turns outward. The white corneal reflex will be moved inward toward the nose. Maddox rod test. Introduction. Maddox rod is made up of series of parallel plano-convex cylinder lenses. As they are made up of plano-convex cylinder lenses, it will convert the image of a point light source into a streak due to its optical properties. And if we use a red Maddox rod, then it will also change the color of the streak. It will be red in color. Principle of Maddox rod test. This test is based on the principle of diplopic projection. While seeing a point light source, the eye wearing Maddox rod will see a red line or streak, and in the other eye will see a point light source. If the eye is orthophoric or there is no deviation, then the final image will be superimposition of both eyes image. That will be point light source at the center of the streak or red line. And if deviation is there, the position of this streak in relation to the image of the light source seen by the fellow eye indicates the presence and amount of tropia and phoria. Always remember, red line or streak belongs to the fixating eye or eye wearing the Maddox rod, and point light source belong to the deviated eye or the testing eye or the eye not wearing the Maddox rod. Now let's see what are the requirements to perform Maddox rod test. We need patient, trial frame, fixation target, that is point light source, Maddox rod streak or Maddox rod trial lens. This test can be done at near as well as at distance. When testing at near, the patient is to fixate on a light source at 33 cm, which is held at eye level. When testing at distance, the patient is to fixate on a light source at 6 meter. Prerequisites to perform Maddox rod test. First, we need to do cover test to identify fixating eye, because we need to put the Maddox rod in the fixating eye. So first, we will identify fixating eye by using cover test. In case of alternate phoria or tropia, we can do this test as a confirmatory along with other tests, but we won't be able to measure the deviation as both eyes having deviation alternatively. It will affect the accuracy. Procedure of the test. Measuring horizontal deviations. When performing this test, the room lights should be dimmed and only one light source should be visible. Patient is instructed to fixate on the light source with both eyes opened. The Maddox rod is then placed over the fixating eye. Let's consider right eye is fixating eye. To measure horizontal deviation, Maddox rod lines are placed horizontally so that a vertical line can be formed. The patient is then asked whether white light is superimposed on the red line or not. Three responses are possible. Vertical red line and point light source is superimposed. Point light source is right to the vertical red line. Point light source is left to the vertical red line. Patient response is point light source is superimposed at the center of red line. Interpretation: orthophoria or normal retinal correspondence or simultaneous macular perception. Patient response is point light source is right side of the patient or left side of the examiner in relation to the red line. Interpretation: left exotropia or crossed diplopia. Patient response is point light source is left side of the patient and right side of the examiner in relation to the red line. Interpretation: left esotropia or uncrossed diplopia. Always remember, the shifting of image is opposite to the direction of deviation. If the eyes moves in or iso, the image will moves out, and if the eyes is move out or exo, the image will shift in. Measuring vertical deviation. The Maddox rod line is placed vertically in front of fixating eye, that is right eye, so that a horizontal red line can be formed. Patient is then asked whether white light is superimposed on the horizontal red line or not. Three responses are possible. Horizontal red line and the point light source is superimposed. Point light source is up to the horizontal red line. Point light source is down to the horizontal red line. Patient response is point light source is superimposed with the horizontal red line at the center. Interpretation: orthophoria or normal retinal correspondence or simultaneous macular perception. Patient response is point light source is up of the horizontal red line. Interpretation: left hypotropia. Patient response is point light source is down of the horizontal red line. Interpretation: left hypertropia. Can we measure torsional deviation with single Maddox rod test? The answer is no. Torsional deviation is not possible to identify with single Maddox rod. For torsional deviation, we have to do double Maddox rod test. In single Maddox rod test, point or circular image is formed in deviated eye, which won't change its shape as it's circular. If it's possible to form a line in the deviated eye also, it will give best interpretation for torsional deviation. This is possible with double Maddox rod, in which red line is formed in fixating eye, that is wearing red Maddox rod. White line is formed in deviated eye because of transparent Maddox rod. Hirschberg corneal reflex test. Hirschberg test is an objective test performed with a simple pen torch and gives rough objective estimation of angle of a manifest squint. It uses first Purkinje image to assess alignment of eyes or potential strabismus. Being an objective test, it can be used in young and uncooperative patients or when fixation in deviating eye is poor. The Hirschberg test is also known as the corneal light reflex test because in this test we assess the reflex of point light source in patient's eyes. Procedure of the test. Patient sits at a distance of 50 cm from the examiner. Examiner turn on the pen light and direct it towards the midline of the nose, that is middle of the eyes. Then instruct the patient to look at the light. Now examiner placing his eyes directly behind the pen light. Observe the corneal light reflex from the both eyes. The degree of strabismus can be roughly estimated by measuring the decentration of the reflex from the center of pupil in millimeters. 1 millimeter of the deviation of the reflex is equal to 15 prism diopter. Remember these points. 1 degree is equal to 2 prism diopters and 1 mm is equal to 7 degrees or 14 prism diopters. Now documentation. Observation: a reflection is center in each pupil. Interpretation: orthoposition or normal alignment. Observation: reflection is decentered temporally from the center of pupil. Interpretation: esotropia. Observation: reflection is decentered nasally from the center of pupil. Interpretation: exotropia. Observation: reflection is decentered downward from the center of pupil. Interpretation: hypertropia. Observation: reflection is decentered upward from the center of pupil. Interpretation: hypotropia. Always remember the corneal reflex is decentered opposite to the deviation of eyes. If the eyes move in or exo, the reflex will go out. If the eyes moves out or exo, then the reflex will move in. Now estimation of deviation by Hirschberg corneal reflex test. Accuracy is less because this is an objective test and we are not using any prism to measure the deviation, but it's quite good for rough estimation of deviation. If the reflex is in between the center of pupil and pupillary margin, rough estimation of deviation is 7 degree or 15 prism diopter. If the reflex is at pupillary margin, the rough estimation of deviation is 15 degree or 30 prism diopter. If the reflex is in between the pupillary margin and limbus, then the rough estimation of deviation is 30 degree or 60 prism diopters. If the reflex is at limbus, rough estimation of deviation is 45 degree or 90 prism diopters. If the reflex is at sclera, more than 45 degree or more than 90 prism diopters. Duochrome test. This is an subjective test used to identify monocular spherical endpoint in subjective refraction with the aim of keeping accommodation balanced or relaxed. In Duochrome chart, letters on green background and letters on red background are there. Now, principle of Duochrome test. This test is based on chromatic aberration of the eyes. In chromatic aberration, rays with shorter wavelength focus in front and rays with larger wavelength focus behind the focal point. Green light has shorter wavelength than red light, due to which green rays focus in front of red rays. In myopia, due to increased converging power, red rays fall closer to retina and seen clearer than green. And in hyperopia, green is seen clearer than red. If red and green rays focus equally from the retina, both color will be seen equally clear and accommodation will be balanced. Now, procedure of Duochrome test. Prerequisites. Room illumination. Room illumination should be dim light condition to increase chromatic aberration of eyes. Retinoscopic power, both spherical and cylindrical power, should be given. Untested eye should be closed. Procedures. Patient is asked, are the letters in red background darker, clearer, or the letters in green background are darker, clearer? If patient response is the letters in green background are darker, clearer, then keep at plus 0.25 diopter spherical step until letters on the red-green chart appears equally dark, clear, or when a reversal occurs. If patient response is the letters in red background darker, clearer, then keep at 0.25 diopter spherical step until letters on the red-green chart appears equally dark, clear, or when a reversal occurs. The power required to make the letters on red-green chart appears equally dark, clear is added with the retinoscopic power. Let's try with an example. Retinoscopic power is -2 diopter spherical, and in Duochrome test, patient is seeing letters on green background clearer. After giving plus 2.5, again patient is seeing letters on green background clearer. Then after giving further plus 0.25, total plus 0.5, letters on both background are equally clear. So the final power will be -2 plus 0.5 or -1.5 diopter spherical as spherical endpoint. Stay with smart optometry and study optometry smartly.